Hi everyone, welcome back. So in this video, we're going to be talking about why scaling works. We've seen scaling where we can multiply the numerator and denominator by the same number and then get a new fraction, which although it looks different, it still retains the same value. For example, here, if we look at these two fractions, we have 1/3 and we have 2/6. These are, if you look at their area models, they have the same area shaded, so they represent the same information, the same value. So that means that we can actually say they are equivalent or equal to, and we can see that they are equal, or we can get one of the fractions to look like the other one if we multiply by 2. Remember, if we are able to find the number that they multiply by, it has to be the same number. If we're able to find the number which we multiply by and it's the same one, then we can say they're equivalent. So these two are equivalent because you can multiply numerator and denominator by 2. But why does this work? Why is it okay to make these little arrows and multiply by 2? Again, these arrows are a bit of a shortcut. It's easier for us to see what it is that we're actually trying to do with the numbers. But if you really want to know, like, why is it that 1/3 is the same as 2/6, right? Because they are different numbers, and we do have area models to see that. But if you want to see it like mathematically, we need to first go over a few rules about numbers, and we'll see that this follows the same rules as the other numbers. So first rule I want to talk about is multiplying by 1, right? So if I have 5 times 1, that gives me 5. 4 times 1 gives me 4. 3 times 1 gives me 3. So no matter what I multiply by 1, I get the same number back. Same thing when I divide, right? If I say 10 divided by 1, that's 10. 12 divided by 1, that's 12. 6 divided by 1, that's 6. So no matter what, if I divide by 1, no matter what it is that I'm dividing, I get the same number back. So multiplying by 1 and dividing by 1 does not change the value of the number. Next, other rule that I want to talk about has to do with fractions. If I have a fraction with the same numerator and same denominator, it is equal to 1. So if I have 4/4, that equals 1. 3/3, that equals 1. 7/7 equals 1. So no matter what the numbers are, right, 322 over 322, that equals to 1. No matter what the numbers are, if the numerator is equal to the denominator, then it's equal to 1. We need these two rules in order to understand why scaling works. Okay, so let's take a look at the example that we just worked on, right? 1/3 gives us 2/6. Now, what we're actually doing when we draw these arrows up here, we're actually multiplying by a fraction. The way you multiply by fractions is that you multiply the numerators together. So this will be a 2, and on top of a 2. So then we have 1 times 2 gives us 2, 3 times 2 gives us 6. But if we look closely here, we can see that this 2/2 is actually a large 1, right? Because it's can make it look like a 1. So that's why the value 1/3 is still the same as 2/6, even though they look different, because what we're actually doing is we're multiplying by 1. Right here we are multiplying by 1. So we're not, anything you multiply by 1, you should get the same number back. So that's why 2/6 is the same as 1/3. I'll do one more quick example. Again, this is just explaining why scaling works. If it makes sense to you, like doing the arrows and multiplying the numerator and denominator by the same number, that's fine. Get used to that, practice it, and then once you get that, once you're comfortable with that, you can go ahead and try it this way, and this will give you a much better insight as to why scaling actually works. So let's try one more example. Right, so let's take one. We'll take one that we know, right? We know 4/8, and I can scale this to, let's see, you can pick any number, right? We can multiply by 2. Or let's not do 2, let's do 3, because I feel like maybe we did 2 too many times. Or 5 times 5. So that would give me 20/40. And if we want to, again, look at these numbers in more detail, we would have 4/8. And it's equal to 20/40. And as mentioned before, what we're actually doing is we're multiplying by 5, right? So times 5/5. The way we multiply fractions is numerator times numerator, denominator times denominator. So 4 times 5 is 20, 8 times 5 is 40. And as mentioned before, what we're actually doing is we're multiplying by a giant 1. So that's why the value doesn't change. Even though it looks different, it's still the same because we're technically just multiplying this 4 over 8 times 1. Let's do one last example again, just like this one. Say I have the fraction of 5 over 10. Like we know that should look like 1/2, right? So we can actually scale down. Remember when we were scaling down before? When we divide by the same numerator, same number, so divide by 5, divide by 5. That'll give me 1 over 2. Now let's look at it a little closer. So we would have 5 over 10, and that becomes 1/2. So as mentioned before, we are dividing this time though by 5 over 5. That is a giant 1. So when we divide by 1, it doesn't change the value. It changes the way it looks, but it doesn't change the value, right? When we divide by 1, we get the same number. When we multiply by 1, we get the same number. So in both of these cases, we have 4 over 8 times 5 gives us 20 over 40. But what's actually, like, this is great notation. Like, this is good if you get it this way. But what's actually happening is the following. We're multiplying by 5 over 5. Right, here's the 5, here's the 5, is these 5s. And then those two together become a giant 1, right? 1 whole. 5 over 5 is 1. So we're actually multiplying by 1, which gives us the same value. Even though it's different, it should be the same value. Same thing here. We're dividing by 1, so it should give us the same value. And our 1 in this case is 5 over 5. So hopefully this helps you understand scaling a bit more, and how even though we're multiplying or dividing by another number and it looks different, they still have the same value. And that's mainly because what we're actually doing is multiplying by 1, or we are dividing by 1. So either way, we're not changing the value, it just changes the way it looks. And right, we've seen with area models how they can look different, but they have the same value. Again, please go and practice this, make up your own problems, try to see if you can figure it out. A lot of math can be learned by just like trying and attempting these problems yourself.